Algebra 1/2 Lesson 102. Caleb, as you'll remember, my tried and true color died in the last lesson. I wrote lesson 102 with this marker, and then I decided it's too hard to see. It's really light in color, and it's also really fine pointy, so it's hard to see. So I'm switching out to black. This will be interesting. Example 102.1. Oh, the topic of this is adding like terms, part 2. I didn't know there were parts, but okay, so we're going to step it up a little bit. All right, here's the first one. It gives us two terms, 2xy squared, 3y squared x, and 7yxy. And it asks, are these terms? Okay, that's a good question. Here is what we need to have like terms. That means we can have different numbers. Right? The 2 and the 3 and the 7, that's not a problem. But we have to have the same letters. And we have to have the exponents in the same places. I'm not writing this out in completely accurate language, but you know what I mean. The numbers on the front can be different, but we have to have the same letter variables, alpha variables, with the same exponents, okay? So like in this one, there's a y squared and the x is just to the first power, we can say that, right? That it has to be the same. The y has to be the squared, y squared has to be the same in all the terms. Okay, I'm gonna stop talking and look at this. What helps very much is if we have a standard order that we can write our terms in so that they're easier to compare. So that's why I always go much combining of like terms. So this one looks really good. This one I'm going to rewrite. Let me just do this. 2xy squared. That's the same. This one, I see they're not alphabetical. So I'm going to carefully rewrite that, making sure I put the exponents in the right places. And then this last one has not been written in exponent form. Now that I've cleaned everything up, I see, yes, they are like terms. And that's the answer that John was looking for. He was looking for a yes or a no. Okay, so yay, that's fun, easy. Next one, 102.2. Now we have a big long string. I'm going to copy it down for you. 4x plus 3. And it's going to be a challenge to see if I can get it squeezed in here. Double check. 4x plus 3 plus 6x plus 4 plus 2xy plus 3yx plus 2. Okay, so we want to simplify this by adding like terms. Those are our instructions. I always start with the most complicated term first. So I look through these, I go, okay, I've got x, I've got a plain number. Here I've got an xy. I recognize these are the same. This one's just written in the opposite order. So I'm going to mentally flip that into alphabetical order. I'm going to recognize they match, and then I'm going to add the numbers. So it's 5xy. Okay? Next one are the x's. Notice how I mark this up. I use different lines and circles and squiggles, whatever I want, just to match. It helps so much, and it also helps you make sure you've got all the pieces reflected in the answer. This is going to be 10x, and then let's double underline these. 7, 8, 9. Okay, notice how these are written in what we would call the descending order. Double checking my answer. Now, John puts them in a different order. John writes 9 plus 10x plus 5xy. No, he writes 5. Yes, he does. This is John's answer. Is ours the same as his? Yes. Different order, same terms. Everything's the same. The signs are the same. Now, is John's just as good? John's isn't wrong. It's perfectly fine. But here's the thing. If we can keep our work in a certain reliable order, it's always going to help us. Just like here, it's much easier to compare these if we have a certain reliable order. If we have a certain reliable order in our expressions, it's going to make our work much more organized and logical. So, I disagree with John. I think this is the better answer. Right from the beginning, we always want to work on keeping our answers as orderly as possible. And now we just have one more problem in this lesson. Here we go. As you get better at these, I'm just going to show you in the book. You don't have to copy all of this. You can just look through it here and go, okay, x squared, oh, and then that's an x squared, right? You don't have to mark it up as much when you can do it in your head. And then you go, okay, that's 5x squared. Now let me look at the x's. See what I'm saying? But write it out for a while so you can mark it and make sure that you really got the hang of this. Example 102.3, I know, writing's a chore. 4 plus 3x squared plus, now see, I'm going to write this just the way it is in the book, but you could fix that and write 2x squared if you wrote it down. Plus 7. Okay, just double checking to make sure I didn't forget anything. Okay, again, I like to go for the highest order term. There it is. This is 2x squared. So we've got 5x squared. And then I'll go for I'll use squiggles this time. So this is my version of the answer. And again, John has the same terms. He has 5x squared, and he has 7x, and he has 11, and he's adding them all together. But he puts them in a different order. Train yourself to do it this way right from the beginning, and you'll be glad. Lesson 102 is history. Yay, Caleb. I will see you next week for 103, which is a gem.